Okay, let's work out a couple of these questions from the release test questions. And first one is involving scientific notation, because the radius of the Earth's orbit is a big number. And what is the number in scientific notation? So I say that in jest because scientific numbers describe really large objects and also really small objects. And so this 150 billion is a large number. And so how would we describe that in scientific notation? Well, what it does is it takes a large number and truncates it, makes it smaller, concise, compact. And so let's do that. Let's take this number and shrink it down. So there's some rules that you have to follow when doing that. First of all, you must always identify where your decimal is. And so there is something called a hidden decimal. So by writing this number out, you'll see that the hidden decimal is here. Okay, and there it is. And so once you find the hidden decimal, then you move the decimal a certain number of digits so that the number you create is between 1 and 10. So let me repeat that. You're creating a number between 1 and 10. And how you do that is you move your decimal a number of digits and stop in the position that creates a number between 1 and 10. That would be 150. Keep going. 15. Nope, not between 1 and 10. And finally, 1.5 or 1.5. And so that does it. And so that's my number between 1 and 10. And then you count the number of spaces that you move the decimal to create the number between 1 and 10. So that was 3, 6, 9, 10, 11 spots. And that number 11 becomes the second half of your scientific number, times 10 to the 11th power. Now, you're multiplying by 10 to the 11th because essentially each time you multiply by 10, you add a 0. To multiply by 10 again, you add another 0, which is 2 zeros. And so by moving this decimal over one spot, it's like multiplying by 10. Move it again, multiplying by 10 again. And so this keeps track of how many times you're multiplying by 10. And we multiply by 10 11 times to move the spot back over to the original position. So 10 to the 11th will take 1.5 and move this decimal over 11 spots to the right back to its original position, which makes it a very large number. So again, if you're looking at a large number, then typically your exponent is a positive number. Okay, it's not a negative number. So the rule is that when you move your decimal to the left, you count the number of places you move it, and the number itself is positive in the exponent. Okay, so 11 spots to the left, positive 11 in the exponent, and that is the answer. Okay. Looking at the next question, number 2. Okay, number 2. Oh, not too far. So number 2, here we're taking a scientific number and writing it in standard form, it looks like. So what this says is that you now have a number. You identify the decimal. And what this says is that you're taking 10 and squaring it. And so that would mean essentially that you're taking 10 times 10, which is 100. So it would be 3.6 times 100. If you multiply out, you end up with 360. So it's 360. Now, so this would be the long way of doing that. Again, multiplying this out. The shortcut would be the positive exponent 2 means that you move the decimal 2 spots in the positive direction to the right. And so this would be 1 and 2. So this blank spot here is where you add a 0, leave the decimal there, and that becomes your number, 360, okay? Here's another example of writing a number in scientific notation. This number is a very small number, so we're going to have a negative exponent. And what we'll do here is identify the decimal, okay? Now let's move it over how many spots to make a number that's between 1 and 10. It would be 1, 2, 3, 4, 5, 6. That's 0.7. 0.7 is not between 1 and 10. It's smaller than 1. So between 1 and 10, I've got to move it over one spot more, and that's 7. And so my number would be 7, right? The decimal is moved 1, 2, 3, 4, 5, 6, 7 spots. So it's times 10 to the negative 7th power. Again, that negative 7 says that in order to move the decimal back to the original position, I would have to move it left 7 spots. You see? So again, a small number written as a scientific number in scientific notation. You move the decimal, and the sign is negative. So move the decimal, count the spots, and the sign is negative. Again, the rule is that when you move the decimal to the right, converting a standard number to scientific, your exponent is negative. Answer is B. And one more question. It says we have a 5-member band. And they are, let's change that up here. Let's fix that. Don't like the way that looks. Okay. A 5-member band. They'll get new outfits. Shirt costs $12 each. Pants cost $29 each. Boots cost $49 a pair. What is the total cost of the new outfits? So if there's 5 people in the band, then you're going to have to buy 5 shirts, 5 pants, and 5 pairs of boots. So that's how you would find the total cost. So 1 shirt, 1 pair of pants, and of course a pair of boots. So that's for 1 person. So for 1 person, the total cost, here we go, let's figure this out. For 1 person in the band, your total cost is going to be what? $12 plus 29 plus 49. So adding that up, we end up with 9 plus 9 is 18. 1920, so it's 20. Carry the 2. 2, 1 is 3, 5 and 9. So it's $90 for 1 member. So 1 person costs $90 for an outfit. But we have 5, right? So for the whole band, for 5 people, we're going to multiply by 5. So it would be 90 times 5. That's 9 times 5. 45. So 90 times 5 is $450. And that is your answer. 450 C. Alrighty, that's a wrap. Remember, study hard and learn a lot. Bye-bye.